In this section, we're going to take a look at the idea of what a polar coordinate and then also what a polar function is. And so the main objective of this section is to make sure that we can plot a polar coordinate and understand what a polar coordinate is, to convert back and forth between Cartesian as well as polar coordinates, and then to be able to graph a polar equation using technology, and then finally to be able to convert a polar function into a Cartesian function and then graph it. And so sometimes we have these sorts of relations that don't necessarily meet the functional definition in Cartesian coordinates. And it's easier to use a polar coordinate system. And this is mostly true when we start dealing with things like circles or other things that are conic sections, which we're going to look at a little bit later in the course. So the polar coordinate system is based on an angle and a radius. And essentially, r is going to be the distance from the origin, whether it be right or left. And then theta is going to be the angle swept from terminal position, okay, whether from the x-axis. And generally, if r is positive, it'll be in quadrant 1. If r is negative, it would be in quadrant number 2. And we just sweep the angle out, and then we end up at some terminal point. Whenever we use polar coordinates, they're of this form, r comma theta. All right, so we're basically going to have a radius and an angle, and we're going to plot a coordinate, not an angle, that's going to correspond to that. Usually we call the center of the axis, we usually call that the origin. We're going to call that the pole. All right, so the pole is basically going to be this coordinate, which I'm drawing in the middle. That's going to be our pole. All right, and essentially, if you wanted to plot the point 2 pi fourths, you would move to the right 2 units, and then you would sweep an angle of pi fourths. So that would be the angle theta is pi fourths. So that's how we plot a polar coordinate. And that's going to be the crux of everything that we're going to be doing in this section, is making sure that we can plot polar coordinates and understand their relationships. So for an example, let's just plot a number of polar coordinates given those. All right, so the first one we have is 2 comma pi 6. So what I'm going to do is I'm just going to go to the right 2, and then I'm going to draw an angle of pi 6, okay, or about 30 degrees. Now, this line right here, or that curve, doesn't exist. So essentially, when you're done with it, even though the angle exists where theta is equal to pi 6, we just get rid of that, okay? So, so essentially, you're just plotting it, and that's going to be the coordinate 2 comma pi 6. Really easy to do. If we had the point 3 negative 2/3 or 2 pi thirds, we'd go to the right 3 units, and then negative 2 pi thirds is in this direction, and we know negative 2 pi thirds ends right about here, a little bit less than that. All right, so maybe right about here. And our theta is negative 2 pi thirds, and then the radius, if this were a circle, all right, so just think of this as like a circle, the radius would be equal to 3 for that circle. So now we don't necessarily care about any of the perforated lines, so we would get rid of those and all this stuff, and we're just really interested in that ordered pair. Okay, so let me redraw this. Unfortunately, I erased it. So this is 1, 2, 3. And so this would be the point 3 comma negative 2 pi thirds. So it's pretty easy to plot these points. All right, we just make sure that we use our general directions of angles and radii. All right, now another ordered pair. Let me refresh this so we can clear it out. So we have negative 2 and 7 pi 6. So on our graph, we would go to the left 2 units. So this is negative 2. And then 7 pi 6, we know is just a little bit bigger than pi. All right, it's going to be 210 degrees. So maybe right about here. All right, if this angle theta were 7 pi over 6. All right, and so this would be the point negative 2, 7 pi 6. Negative 1, negative 8 pi thirds. All right, so now negative 8 pi thirds is bigger than 2 pi, okay? In fact, we know that if we took negative 8 pi thirds and we added 2 pi to it, we could find a coterminal angle to that, okay? and that would be negative 2 pi thirds. All right, but realistically, we are going to go around twice for this. All right, so if we refresh this, just so we have a new platform to work with, then we have negative 1 and negative 8 pi thirds. So we would go around one time. Okay, so that's the 2 pi for that. And then 2 pi thirds negative would end up, if I were to draw it, maybe right about here. Okay, so in reality, what we can say is that the point, now this is the point negative 1, negative 8 pi over 3. And that's the exact same coordinate as negative 1, negative 2 pi thirds. All right. It would also be the same coordinate as negative 1. And then if we went around this way, we draw it in a different color. So that way we can see that there's an infinitesimal number of ordered pairs. If we drew it this way, all right, then theta could be 4 pi thirds, all right, in the positive direction. So another way to plot this would be 4 pi thirds, or negative 1, 4 pi thirds. And then if we added another 2 pi to that, we get 10 pi thirds, 16 pi thirds, 22 pi thirds, etc. And they would all be the same terminal point, okay? So basically, we just have an infinite number of different points to where we could plot these. Right? Now, finally, this last one that we have is negative 4 and negative 17 pi twelfths. All right, now 17 pi twelfths is a little bit bigger than pi, but it's not as big as 3 pi halves. Okay, so we would go back 4. And negative 17 pi twelfths would go this way. So let me draw that again. It's not a good drawing. So we know that this right here would be pi, all right? And then we have 5 pi twelfths left, which is a little bit less. So we might end up right about here, okay? And of course, if you're not sure, you can always just convert this into degrees, right? We could take negative 17 pi twelfths and multiply it by 180 over pi, right? And then we could just cross cancel some things out, all right? And if we were to do that, we should end up with 240 degrees negative, all right? Just because I know it's 30 degrees less than if it was negative 18 pi twelfths, all right? So this angle right here would be negative 17 pi twelfths, all right? And the point, and again, we don't want this. Well, we wanted the point, it just went away. All right, but this would be our point, negative 4, negative 17 pi twelfths. And of course, if we wanted another coterminal sort of point there, we could just add 2 pi to that, okay? So another point, if I were to add 17 pi over 12 plus 2 pi, which is the same thing as 24 over 12, that would be equal to 7 pi over 12ths. So another point could be negative 4 and then 7 pi twelfths, all right, which would be this way. Okay, so that's a couple ways that we can make sure that if we were to be bound by a specific angular domain, that we can make sure we're within that angular domain. Okay, so that's how we plot polar coordinates. Pretty easy. So in the next section, what we're going to do is we're going to learn how to go back and forth between polar and Cartesian coordinates. And then we're going to start learning how we go through and convert these polar equations into Cartesian equations.